Hello guys, today we will learn continuity. And for a function to be continuous at closed interval a and b, it has to be continuous at every point of its domain. So let's say that I have a point C here. How do we tell whether a function is continuous at C? Well, the limit of the function as x approach C should be exist. And exist means that the limit from the right should be equal to the limit from the left, and it should equal to FC. What about the A and B? Well, to study the continuity at these endpoints, we are going to study the limit from the right side of A, the limit from the left side of A, and it should be equal to FA. So at A, the limit of the function as x approach A from the right should equal to FA because the limit from the left is not there. Also, the limit of the function as x approach B from the left should be equal to FA. Okay, these are the main rules to tell whether a function is continuous or not. Now, let's try to tell whether a function is continuous at every point in its domain here. Well, by looking at this, we will realize that at x equal 2, the function is undefined, so it's not continuous. So here, the function is not continuous at x equal 2. And the reason, because the function is undefined at x equal 2. Okay. Yes, the limit is exist, but it does not equal to f2. Okay. Now in this case, we're studying the continuity from -2 all the way to 6. Okay. So by looking at 6, what is the problem here? The limit from the left side is exist, but the f6 does not equal the limit from the left, so we can say it's not continuous. And the reason, because the limit of x as approaching 6 from the left side of the function does not equal f6. Okay, that's the reason. Now what about here? Well, the endpoints, the limit from the right side equal to the f-1, limit from the left side of 3 equal to f3, but I have a problem here. What happened here? The limit from the right side equal to 0, limit the left side equal to 2. So the limit does not exist. So it's not continuous, and because the limit x approach 1 does not exist. Does not exist means limit as x approach 1 from the right does not equal to the limit as x approach 1 from the left side. Okay? Now in this question, you need to find all the points in which the function failed to be continuous. If I factor the denominator, I'm going to get x minus 5, x plus 2. This is a rational function. We know that these points at x equal 5 and x equal -2, there is a vertical asymptote. So x cannot be equal to 5 or -2, right? So the function is going to be discontinuous at x equal 5 and x equal -2, right? So we can say that the function is continuous at all real numbers, but not -2 and 5. Okay, why? Because at x equal 5 and x equal -2, we have a vertical asymptote. X equal 5 and x equal, -2 are classified as non-removable discontinuity. Okay, now what about this one here? Well, in this case, if you try to factor, you will realize that you can cross out these two. Okay, so what happened here? The function is f(x) is discontinuous at x equal 2, but x equal 2 is a removable discontinuity because we can cross it out. When you graph it, that's going to look like as a hole. So that's going to be a straight line. And at x equal 2, we will have a hole. Okay? Okay, what about this question here? Okay, in this case, we're talking about a function from -2 here, 0 here. What we are going to do, we'll study the continuity at -2 and continuity at 0. The limit should be exist. It should be equal to f (-2) or f of 0. So now we're going to look at -2 first. So let's start to study the limit of the function as x approach -2 from the right side. Well, from the right side, we're using this function between -2 and 0. So it's going to be limit of -x as x approach -2 from the right side. Substitute and you are going to get 2. Now we need to study limit as x approach -2 from the left side of the function. From the left side, it's anything less than -2, we are using 2. So it's going to be a limit of 2 as x approach -2 from the left side. This is a constant. It will be equal to 2. So the limit is exist because the limit from the right equal limit from the left. Now we need to find f (-2). Well, f (-2) is going to be here because I have an equal sign, so equal to 2. Now, you notice that the limit is exist and equal to 2, and it's equal to f (-2, then the function is continuous at x equal 2. What about at x equals 0? So one more time, -2 and 0. We need to study the limit from the right, left, and f(0). So limit as x approach 0 from the right side, which is greater than, we'll use this function, which is equal to -1. And the limit as x approach 0 from the left side, you are using this, -x, and that's equal to 0. Okay, you don't need to find f(0). You can, but you don't need to actually, which is equal to -1. Now, by knowing this, limit as x approach 0 does not exist. So fx is not continuous. Okay, at x equal 0. Now, is this a removable or non-removable? Well, this is a non-removable, okay, discontinuity. Now in this question, they want us to find the value of a here for this function fx if we know that the function is continuous at every x. Okay, well, let's go back to the definition of continuity. What does it mean the function is continuous at every x? If we look at the number line here, there's 3. Any number less than 3, we're going to use x squared minus 1. And any number to the right of 3, greater than or equal to 3, we're going to use 2ax. Now, a function continuous means the limit as x approach 3 from the right will be equal, for the function, will be equal to the limit of fx as x approach 3 from the left side, and that's going to be equal to f3. Okay, so the limit is exists and equal to f3. Okay, guys, now let's try to find a by using the same definition, limit of x approaching 3 from the right side. We are going to use this function here, okay, 2ax equal to the limit as x approaching 3 from the left side, and we are going to use this function now because it's from the left side, numbers are less than 3. Okay, now time to calculate this limit. So if x approaching 3 from the right side, we are going to substitute x by 3, so it's going to be 2a3 equals, same here, 3 squared minus 1. That's going to be 6a equal 9 minus 1, which is 8. So a will be equal to 4 over 3. Okay. Let's move on to the next question. Okay. So one more time, we need to find the values of a if the fx is continuous. So we're going to again look at 2. From the left side of 2, we are using less than 2, we are using 12. Greater than or equal to 2, we are using a square x minus 2a. Now, by calculating the limit, as x approach 2 from the right, we are using a square x minus 2a equal limit as x approach 2 from the left side, and it's a constant function, 12. By substituting x by 2, we are going to get a squared 2 minus 2a equal 12. Now, this is a quadratic equation. Move 12. It's very clear that 2 is a common factor. You can divide all the equation by 2. You're going to get, now you could factor it. So it's either a equal 3 or a equal negative 2. So if a equal 3 or negative 2, the function will stay continuous at every x. Moving to the next question. In this question, we're following the same thing. So a number line, here is 0. Numbers to the greater than 0, we're using x squared plus b. Numbers less than 0, we're using x minus b over b plus 1. Now let's find the limit. From the right side, we are using x squared plus b. As x approach 0 from the left. Substitute x by 0, we're going to get b, negative b over b plus 1. Cross multiply, expand, and move the b. Now you can take b as a common factor. So it's either b equals 0 or b equal negative 2. Okay, so if b is 0 or negative 2, the function of x will be continuous. Moving to the next question. We need to find the values of a and b to keep gx continuous at every x. Okay, let's try to draw the number line here. Here we have 0 and 2. If I take a number less than 0, I'm using this function, ax plus 2b. And if I take a function, a number between 0 and 2, we are using this function here, which is x squared plus 3a minus b. If I'm taking numbers greater than 2, then I'm using 3x minus 5. Now, in order for gx to stay continuous, the limit as x approaches 0 from right and left should be equal, and the limit as x approaches 2 from the right and left should be equal. So we are going to study the limit twice, as x approaches 0 from right and left, as x approaches 2 from the right and left. So let's start with 0 first. Limit as x approaches 0 from the right side, we are using x squared plus 3a minus b equal the limit as x approaches 0 from the left side, which is going to be ax plus 2b. Substituting x by 0, we're getting 3a minus b will be equal to 2b. Now you can simplify this by moving the 2b. So 3a minus 3b will be equal to 0. Dividing everything by 3, a minus b will equal to 0. That means a equal b. Now, from the other side, let's try to find the limit. As x approaches 2 from the right side, we are going to use 3x minus 5 equal limit as x approaches 2 from the left side, x squared plus 3a minus b. Substitute x by 2. We're going to get 3 times 2 minus 5. 3 times 2 minus 5. 2 squared plus 3a minus b. Okay? And that's going to make it 1 equal 4 plus 3a minus b. Try to simplify it. Okay, now we have two equations here. We have this one and we have this one. We can use substitution method to solve the equations, remember, and we can substitute b by a in this equation. So by substituting, because a equal b, right? So we're going to substitute b by a. So we're going to get 3a minus a equal negative 3, 2a equal negative 3, so a will be equal negative 3 over 2. So we found a. Now in order to find b, well, we know that a equal b, so a and b will be the same, so b will be equal to negative 3 over 2. Thank you guys for watching. See you next time. Bye.